Okay, and we're live. Hi, everyone. Welcome to another session of the Book Reading Club. This time, this is the second part where we're going to have Venkat Subramaniam talking about his book, Java Functional Programming in Java. And we have here Venkat. So please, Venkat, please introduce yourself.
Hey, thanks for having me. Pleasure to be here.
And we also have our other host, which is Ivan. Please, Ivan, say hi to the audience.
Hey everybody, it's Ivan Ivanov here. You probably know me already. And
Yeah,
we have
and
also Simon.
yeah, also, and we have the pleasure to have Simon with us again. So he was one of the main guys who have this idea of the book reading club.
Yeah, hey guys, thank you very much. I literally just popped in just to try something, actually, because one of the problems with the VJUG site, as I see it, is very often people have to refresh the page in order to have the video start. Do you guys see that at all?
I don't know, maybe.
I notice there's a lot of pain normally on IRC, so I just actually tested something with some embed code that Roberto gave me for this meetup, and it looked like it started automatically. So I was here really just to use this session as a guinea pig, but now, yeah, I was convinced to stay. So I'll have to go in a little while, but I will stay for a while.
Yeah, awesome to have you with us.
Thanks.
Um, so anyway, before we start the discussion with Venkat, I will like to ask the audience that is with us to join us on IRC. You can go to our website virtualjug.com and you have an IRC button. You can join us there. And on IRC, just join the Virtual Jug channel and you can post your questions live, and I'll happy to relay them back to Venkat. Other than that, let's start the discussion. So, Ivan, would you like to tell us what we're going to discuss here today?
Yeah, so after last time we discussed the first four chapters of the book, then today we are going to discuss the other five, which are working with resources, which are closable, then being lazy, which I guess is what Venkat speaks a lot these days. Optimizing recursion with tail calls and so on, and memorization, composing with lambda expressions, and we are going to bring it all together at the end, I hope.
Did you say Venkat was lazy?
That's what I heard too.
Yeah.
No, I said that you are talking about being lazy.
I love being lazy.
Well, that sounds even worse, Venkat. That sounds like you're too lazy to even be lazy. You're just talking about being lazy.
And so, why should we be lazy then?
Well, the word laziness is something that resonates really well because laziness translates to efficiency, and that is the beauty of laziness. There's a huge difference between procrastination and laziness. For example, I was having a conversation this morning, and I mentioned that I don't need to know those details right now. And by saying I don't need to know those details right now, there are two implications. One is there are more important things I need to focus on at the minute, and let's do that. And the second is whatever that we are trying to talk right now can come in later when we have more knowledge and more relevance. In agile development, we talk about something called last responsible moment, but in a way, laziness is that applied to coding, where we postpone evaluation until we no longer can postpone, or it becomes so irrelevant that we don't care to really evaluate it. And that is really the beauty of laziness, is that it gives us efficiency in execution of code. So I think we should be lazy always. Any opportunity to be lazy is a good opportunity to be lazy.
I mean, does it get a bad rep because it's called lazy and people use the word lazy, the term, to mean just someone who doesn't do things? Because I mean, let's say I put off the washing up because I still have plates and cutlery, and I put off hoovering the floor because I'm not tripping up yet, and I put off loads of other things, but then all of a sudden I have loads of family coming around. I have to do everything, and I don't have enough time to do it. Is there a chance that by being lazy, you can actually get an environment whereby an event occurs and you actually are less performant because you have so much to do?
And in a way, laziness in way of procrastination is really bad. There's no doubt about it. But in programming and computer science, we always use terms that are confusing to the outsider, to the beginner. But once we dig in, so here's one thing that really pleases me quite often is when you speak multiple languages, natural languages, and when you interact with multiple cultures, words that mean something in one language or one culture mean something quite different in another language or another culture. Between U.S. English and English, you would probably see quite a few of those as well. And there is a connotation, there is implication of terms, cultural implication of terms. So when you interact with people, non-techies, for example, or in a social setting, the word laziness has a negative connotation. But I think most of us have this ability to switch context very rapidly. So when you start programming and thinking about programming related concepts, the word laziness is not the same word in my mind. It means something entirely different in its context. The connotation is very different. And that happens across different cultures and different group of people that you talk to. You kind of know to differentiate words when you speak about a word. I think the same thing happens in my mind. I never associate the word laziness when I talk about programming to the word laziness with the negative connotation in social setting where you're procrastinating things. That seems to be setting apart in my mind, at least.
Mm-hmm. Yeah, I see that a lot of people do that mistake, and I can pretty much relate with when you say we have people with multiple cultures that they have different understandings on the words that they use, especially for non-native English-speaking people. That's quite hard to translate the words, and sometimes words have different meanings and so on. But I guess I'm deviating a little bit. Anyway, Ivan, do you want to ask the first question?
Something to this laziness thing. So a lot of people are confusing this agile practice of postponing things until latest responsible moment. A lot of people confuse it with latest possible, which is something different, something that Simon said about coming your relatives at home and you don't have the time to clean your dishes. So if you postpone cleaning dishes until the latest responsible moment, then you won't have the problems with your relatives, I would say. So if I can go on with another question about laziness, one of the applications of lazy structures is the so-called infinite streams, right? By the way, I like very much your joke about where do you put the data of those infinite streams? Well, of course, in the clouds, because you can put everything there. So where actually would I need an infinite stream in an enterprise application instead of a collection, for example, that can also extend itself automatically until memory permits?
I think you really pointed out the link between laziness and streams. I think that's laziness and infinite streams. And I think that's extremely important to keep in mind because if you really think about a lot of enterprise applications that we have been working with for the past about 20 years, we can pretty much summarize all of them into one single acronym, which is CRUD. So we typically do create, read, evaluate, and delete. Now, once we get into that mode, we tend to, it's like the saying, a guy with a hammer looks at everything as a nail. And so we've been looking at everything we do as a CRUD application. But a typical enterprise application is a CRUD application because we make it a CRUD application, but it doesn't have to be. There are several things we can look at where either a full application or a significant part of the application is no longer a CRUD application, but where we have a stream of data coming in, and all we are interested in is processing it. For example, look at the stock market, for example. You may have a stream of stock data coming in, and all you are interested in is taking a certain decision based on the stock price and various other details that you have access to. And you need to really react or respond to the information as and when the data arrives. So this really leads into reactive programming. And this was the aha moment for me, because once I got a idea about laziness in evaluation and the composition of functions, it jumped out and I said, wait a minute, that's exactly what reactive programming starts where functional programming leaves. And so where does infinite stream fit into an enterprise application? Well, I think it fits into thinking about reactive programming. It begins to lead us towards data flow kind of architecture, data flow kind of computation, where we got all these data, and as the data arrives, we can start processing it. And the minute we think of data around us as not a collection, but as a stream of data, we begin to see exact things in front of us very differently. For example, what if the mouse movements are a stream rather than being events? Well, mouse moves when mouse moves. A user may move the mouse thousands of times in a second, or they may not move it at all for several minutes. But whenever the mouse moves, the mouse is going to move, and that's a lazy stream, actually. And we don't know how many mouse move activities are going to happen, but whenever the mouse moves, we want to do something about it. Same thing with data arriving from a remote system. It could be a sensor that's relating to us weather data. Imagine there is weather data flowing in, and based on the weather information you're receiving, you have to make predictions as to what you want to do. There are certain businesses that depend very heavily on things like temperatures or forecast of weather, the amount of product they could sell, for example, or inventory they have to maintain, or where they should move things, are dependent on weather data, for example. So when we start looking at data around us as no longer a collection of data, but as a stream of data that keeps on flowing lazily, and if and when it flows towards that we have to do something, then we begin to no longer see apps as CRUD applications, but as data flow applications, as reactive applications. And I think that's where the real fun is. This is an area that most of us don't have any experience in, and we are just beginning to tap into this. And the minute we start seeing this in a different light, I think it changes our algorithms, it changes our design, it changes our architecture, it changes our approach in how we start working with and designing these systems, I think. That's a lot of fun to look at where this is heading towards.
Indeed. So a little bit related to what we were discussing, we have a question here from Ranjit on RC. So Venkat, you gave us a few examples on systems that will be better being reactive, right, and using functional style programming. But Ranjit's question is, what do you think are still the use cases where imperative Java will be better than using functional Java?
So I don't think I can put a blanket statement where one would be better than the other. I think Ranjit's question is relevant, but it also has a trap in it that we are more interested in the classification of things, and I rarely am so interested in classification or grouping of things that way. And the reason I'm not interested in is where it takes us doing that is we try to take a problem and we try to do a very artificial fitting of solutions to problems. And I find that to be rather very ineffective in almost everything I do. And this is one of the reasons why I really, really hate design patterns. And the reason I hate design patterns is what people often tend to do with patterns is they take a pattern and say, give me a textbook listing of where this fits in, and I want to start fitting things into it. Whereas to me, a good development approach has to be where these things emerge out rather than being forced in. And that's one of the reasons why I in my mind personally, I never try to classify this as this is where this is right and this is where it's wrong. Rather, it's a gray area. And I would experiment and say, hey, does this fit better in this context? And even the context may change very slightly, and this may not be a good choice, and the other choice may be better. And I want that flexibility rather than grouping things. So I generally try to avoid classifications where this is the right place to use this versus that's the right place to use that. Keep in mind that both imperative style and functional style are implemented by many different languages today. And all these languages are Turing complete that we are talking about. Well, when a language is Turing complete, you can pretty much solve most practical problems with any language that's Turing complete. Then the question that emerges out of it is, what's the efficiency? What's the performance? What's the elegance? What's the expressiveness? I think that's what these things really come back to. And given a particular problem, if I find that I can make a code expressive and concise and performant in functional style, I would definitely use functional style. If I find that any one of them is lacking, then I wouldn't hesitate at all to go use imperative style, and then be willing to change it to one way or the other, depending on what makes sense. So I wouldn't want to walk around with a list of problems and say, well, that problem fits into this definition, so I'm going to blindly go follow this particular approach. But instead, I think we should constantly reevaluate our thoughts and process, because what may appear to make sense today may not make really good sense tomorrow, knowing something a little bit more or having a better context. So I would avoid that kind of classification or grouping in general.
I see. Yeah, I think that's always like a good approach of looking into problems. Going into something like one size fits all usually is not a very good thing. But going into more practical details, Ranjit's also asking about, so he's going to switch to Java 8 really soon, and he already has a piece of code that's written the old way, imperative style of programming. So he's planning to write the new code using functional style. This means he will end up with both imperative and declarative code in the code base. Do you think this is a bad strategy? What are the options that he can look for when moving from one to another?
Well, in any legacy application, that's completely unavoidable. There are really three options on our hand, and it would become extremely clear which option is actually rather a better option. Option one, don't use any functional style. Don't use any new programming concepts. Leave all the code in the old style. Never improve it. And based on how I say it, clearly that's not a good choice. The second choice we have is throw away all your code base. Completely get rid of it. Start from ground zero. Start writing the code in the newer style. Well, clearly nobody in the right mind would want to do that, because that's not cost effective also. So that literally leaves us only one other option, the third option, which is to really co-mix them and then start using that style that actually makes sense moving forward. I'm not a huge fan of changing the code for the sake of changing. I want to emphasize that. When I start writing new code in existing system, I would start using my newer learnings as I'm writing the new code. But I would never ask people to go in and start changing existing code that actually works right now. And the reason I say that is, if I'm going to start changing existing code, we always have to think of economics of software development. We never want to waste our time and money doing stuff that doesn't provide value and create value to the customers we are serving. So I shouldn't just simply blindly go and say, well, I know functional style now, I'm going to rewrite all my code from imperative functional style. I don't do that personally for my own projects. I wouldn't ask anybody else to do that. But what I would rather say is, when you're starting to write new code, start writing them in functional style. But in the intermittent period, when we're not comfortable with functional style, well, make it work, make it better. Write it in imperative style, and immediately start refactoring it in a functional style. But I wouldn't really go in and change pre-written imperative style code into functional style today. if I'm in that piece of code to make a significant rework of the piece of code, I'm making an enhancement to a piece of code, then I would reconsider refactoring that code and changing it at that time to functional style. But I never would recommend developers to walk into existing systems and start changing imperative code to functional style because they feel functional style is better. Always keep in mind economics of software development, and never really do stuff without fair consideration of that. That's very important for us to keep in sight, I think.
Unless you have a few millions that you can waste to do it.
Oh, even if you do, I would rather take that million and do something more useful with it than change the existing code base.
And
Sure.
I mean, Venkat, I know you develop code with a needle, a magnet, and a very steady hand. But for others who use well-written IDEs like IntelliJ, for example, you do have a number of kind of automated mechanisms which will take the kind of, I guess there's different types of code which you can refactor, right? There's code which can be written in an imperative way, in a functional way, and they're very clear. There are others where you just have a number of callbacks, for example, whereby you can literally just change them into a lambda, and it just makes the code easier to read and well structured. Would you say that kind of thing, whereby you can just get IntelliJ to zip through your entire code base and fix those kind of things, those are straightforward and easy to write? It's the bigger structural changes you're talking about, right?
That's correct. That's correct. And even those changes, I would rather be very reluctant to do it. And the reason is, I am personally not a person who puts entire faith in IDE. Don't get me wrong, no matter what that IDE is. Because if a piece of code in front of me changes in front of my eye, I'm not going to walk away saying thank you. I'm going to look at it. I'm going to ask, what in the world did you actually change? And is this really better change or not? Which means for every change I make, even if the tool is making the change, I'm going to spend my time and energy questioning that. And that involves time, that involves money, that involves cost. And I would argue, if I'm currently working with a piece of code, rather than me manually making those changes, absolutely, I would rather have the tool make the change. But if I'm opening a piece of file because I want to quickly look at what the code is doing, I'm not actively changing that code, and the IDE prompts me to say, hey, here's a candy for you, click on this and I'm going to refactor this code, I'm like, no thank you. I'm not here for that purpose. I have no business refactoring or changing or restructuring this code at the moment. And to have that courage to walk away when that's not your primary business right now is equally important, I think. Otherwise, you look at the version control, and this developer has made several changes to a piece of code, and tomorrow something doesn't work. Now we're sitting there and scratching our head. What are the points that has been touched in this particular change? Why is the code not working? That increases the cost of my debugging. So I think it's important to keep that in mind. It's easy for us to get drawn into. I use the word, and I use this with very specific intent. I call it infatuation, and developers are infatuated. There are probably two kinds of developers, maybe more than that. But those that are averse to things, and that's problematic. But there are also developers infatuated to things, and that's even more problematic. And I think we should never get infatuated with solutions or techniques or just about anything. We need to have level-headedness where we say, I've taken the time to learn this, I've taken the time to understand it, great, but now I will take the time to decide if this is the right moment to utilize it. And I think that's important to have that kind of ability to discern as a mature developer. Otherwise, we go in and we are rampant, we make all these changes, and sometimes we look back and say, did this actually cost us more going through this than had we not made this change? And I think we need to be very deliberate in our changes we make rather than being accidental in the changes we make. I think that's very important. And to me, just because an IDE prompts that we can make changes, however significant or insignificant it is, I call those as accidental changes rather than deliberate changes. And I want every change that I make to a software system to be extremely deliberate. I want to do it because I intend to do it. And now is the moment to do it.
So, coming up with this conversation with Simon and Venkat, we have so Satish over here asking, after changes made by the IDE, as Simon mentioned, running the existing unit test and see if it passes or not won't be that sufficient to validate or change?
I would not use the word sufficient. That's important to keep in mind because I'm a huge fan of automated testing. However, I would give myself too much credit if I were to the belief that my automated testing are foolproof. And if it's especially a piece of code I'm not actively working with, and I'm going to run these automated tests and walk away saying I'm good, is a recipe for disaster over time. And that is the reason why anytime you make massive amount of changes and then rely on automated testing passing, is trouble in itself, right? So again, this is infatuation in my opinion. I want to rely on automated testing, but I'm not going to get too overly confident that just because my automated testing are there, I could make any change in my system blindly and then run the test and say, oh, let's test pass, so I'm okay. I want definitely that human aspect is still important. Why are you making this change? Well, I changed it because the IDE prompted me to make all these wonderful changes, and functional style is good, so I made the change. I don't want that kind of answer, right? I want people to know, here is the code I'm working on, here's the way I wrote it, and while I'm working on this piece of code, I decided to make these changes. Sure, I use the IDE. IDE is a tool for me. I don't want the IDE to replace my intelligence on the project. I want instead me to use the tool, not the tool to use me, right? I think that's important to keep in mind.
Yeah, so actually, I think you already answered this, but still, let me ask you from here, RC here, GR Gab. You're asking if there are any tools to do static analysis to point out benefits in changing code to functional style. I think you already made your opinion clear about that, but still.
And I think there will be more tools moving forward as well. Tools like find bugs and other tools will, start moving towards doing more and more analysis. To me, the most important thing really is not imperative versus functional style code change. The real trick here is, what are the consequences of dealing with mutability, for example? What if you have a mutable variable and you are trying to access that from within lambda expressions? I don't think IDEs are going to prompt you today saying, oh, you shouldn't do that. Well, the language allows you to do it, so I'm going to let you do whatever the language is allowing you to do. But eventually, good tools, good IDEs can come up and say, well, you shouldn't really do that. So consider refactoring this code or redesigning this code. And I think that those are the kind of catches I'm really interested in. I'm not so much interested in saying, oh, this code is imperative, you're bad, go change it. I'm more interested in saying, well, here's a functional style code or an imperative style code you're writing, but here are the reasons why these are bad practices you have followed in this particular instance, and you probably want to go back and reconsider those. I think that is the key important thing to really ask for.
Sure. So actually, people are thanking you very much for all your nice answers and saying that love you. So. So, Ivan, do you want to proceed with your next question?
Sure. So, staying a little bit more in the functional versus imperative style.
I'm imperial too.
Okay, not unit, but style of programming. So, functional style of programming is again modern nowadays, apparently. However, if I'm a kid and start learning programming from scratch, there's a high chance that I start from imperative style, right? I assume that this is because most of the textbooks are written that way. So after you write your first program telling the computer how to do its job, it's a bit hard for you to change your way of thinking. At least it was for me. So what approach would you recommend the young programmers to take? If it is the functional, are there any good sources which a newbie can can learn from? And is there a risk later for them to feel awkward in a project full of imperative code?
Your question reminded me of an experience I think I should share. This was a few years ago. My son was interested in writing a program, and he wrote a JavaScript code to do a game. So he developed a game. This was his first and at this time the last project he actually worked on. But he developed all by himself, and all I did was I taught him TDD, so he knows how to write automated test. And every single exercise we sat together was driven by automated test cases. We would write a test, write a code, write a test, write a code. And then once we were done with these series of exercises over several weeks, I stepped back and said, you're on your own for your project now. My job here is done. You go finish your project. We'll be glad to code review for you. So he, based on the learnings, he implemented the project entirely by himself, which I thought was phenomenal for somebody who never knew programming to be able to complete a complete program, implement a complete program on their own was phenomenal from the learnings. But there were two things he said, when he was programming that I thought were really golden. And he once said, now I know why Dad needs a steady stream of junk food when he codes. And I thought that was lovely to hear that from him. And the second thing he said was, computers are so stupid. You got to tell them every single thing they have to do. I'm like, welcome to the world, kid. And so we are used to these kinds of frustrations when we start coding. But the question really to ask is, if somebody is learning to program, I really think a lot of us are doing it wrong. In the case of my son, my goal was not to teach him programming. My goal was to get him his school project completed, and his school project was to develop a game, and that was my goal. I would even argue, I was thinking about this a couple of days ago, and I was telling myself, I'd never want to teach somebody programming. I really want to teach them problem solving. Because if you really think about it, what do you do every single day? What do I do every single day? We are programming, sure, but more important, we are problem solving. And when people don't understand how to solve problem, and programming is just one problem we are using to solve the problems. And so what I would ask people to do is don't get so tied up into teaching somebody to program. Instead, focus on teaching them about abstraction, teaching them about problem solving. There are some wonderful tools out there where you can learn to program without writing a single line of code. Because the goal is not for somebody to get good at coding. The goal is for them to really understand how to abstract things and communicate with the machine. So there are languages like Alice, for example, where you take objects on the screen and you program your way to tell it where to go. When my son was, even younger than this particular experience I talked about, I got him the Mindstorm, and you program it using visual tools, and then you download it onto the robot, and the robot does things for you. And I'll share with you another experience that was very delightful for me, and it proved how wrong I could be. I wanted to give him a little exercise, and I wanted him to come back to me and say, Dad, I don't know how to program this, can you help me? And the problem I gave him was, you had to put this little robot on the floor. It should drive all the way to the wall, barely touch the wall, and then come back exactly to where it started in reverse. And I gave him this problem. I went away. About 2 hours later, I came down. I was busy with something else. I said, hey, did you give up? Did you not work on it? He said, oh, no, I got it done in about 15 minutes after you left, but I didn't want to bother you, disturb you in your busy schedule, so I was waiting for you to come down to show you. I'm like, wow, really, you got this done? Can you show me how you did it? And he puts the robot, presses the button, it goes all the way, barely touches the wall, reverses back and stops exactly where it started from. I was completely dumbfounded because I wanted him to ask me, how do you program this fact that you're so close to the wall? It's going to involve algorithms and all these. And I finally asked him, how in the world did you do this? And he said, oh, it's very simple, Dad. I first put it here and I, asked it to go for, 2 seconds. It only went about 3/4 of the distance. Then I asked it to go for 3 seconds. It hit the wall. I kept changing the time until it was just about exactly the same time to touch the wall. And that's why I decided to use that particular time in the code. And now it's coming back exactly. And I said, kid, you don't need my help to learn programming. You're fine on your own. And the point really is, we don't want people to get wrapped up or tangled into syntax and imperative and functional style. I believe we are totally going wrong with these approaches. What I really care about is, are you able to solve your problems? Because there's no one solution to a problem. There are so many solutions to a problem, and I want people to learn how to solve problems. That's what I want kids to do, learn about problem solving, not about imperative or functional style of coding. So I would keep them away from the syntax. I would keep them away from programming, syntax and details, and abstract it as much as I can away from that, so that they focus and learn on how to really think algorithm, how to really think of problem, how to think of abstraction. I think that's the most important thing. And so I would not pick books or programming languages like the way we want to teach children. I think one of the biggest mistakes we try to do is we try to teach somebody the way that we do things. And I would first question, is the way we do things is the right way, or is it even a better way? Or maybe they need to learn something very different from what I am learning or what I'm actually doing. So my goal is not to teach them what I do, because if I try to do that, I think I'm failing. Instead, I should be teaching them what they need to really be learning, not what I know. So I think it's important for us to rethink about how we teach children, because the goal is for them to learn the right things, not to learn what we are doing. Chances are, by the time they become programmers, we're going to have different tool set, and why would we want to train them on the current tool set we have anyways?
Guess you could say that, like, it doesn't matter. The code that you write is just a means to an end.
Absolutely, I completely agree. It doesn't matter to beyond a certain extent. It matters when you have to deal with that code. Like Simon was saying on Twitter the other day, you keep looking at the code over and over and over. Well, that would become a problem if the code is not written well. But I completely agree with that statement. At a certain level,
that's a different discussion.
It's an entirely different discussion, absolutely.
So, Ivan, can you please proceed?
Yeah, I think that's enough with abstract and general question. Let us be a little bit more precise, a little bit more concrete. So sometimes when dealing with resources especially, we need to call code that throws checked exceptions, and sometimes we do it inside lambda expressions. And these lambda expressions are usually implementations of or synthesized interfaces that which single abstract method doesn't throw exception. So we cannot simply leave the compiler throw it for us. For example, suppose that for each one-liner, I only want to do something that performs I/O and that throws I/O exception. How would you handle that in an elegant way so that you don't create a big line of code inside your for each method, or where you would put a lambda?
I would first of all step back and say, lambdas should never be multiple lines of code. I once blogged about this, and I mentioned that if you just Google for the following words, lambdas are glue code, you will hit the blog. And seriously, I believe that lambdas are glue code. So within a lambda expression, we should never have more than one line of code. Lambdas to me are kind of like landings. It takes you from one and puts you on the other place. And so in that regard, if a function is doing anything serious and dealing with exceptions is a serious business, I would suggest that it move to a separate method, and what you really want to use is method references in that case. So that's one answer about the way the code is going to be structured, is that you want to use method references. You don't want to put all that code within the lambda expression for sure. But exception itself is a completely different discussion. I think we talked about this extensively last time, and that's something that we need to deal with very separately in terms of how we propagate the error down the stream rather than having to deal with the exception. But coming back to your question, I would put the code that deals with the exception not within the Lambda but within a method and use the method reference. I think that's very critical.
Cool. So we have here a question from our audience again. Let me find it. Here we go. So this is a question from Peter N. So he's asking, because lambdas can access variable of enclosing scope, is it considered bad as the lambda function has some sort of state?
Not at all. And the reason I say not at all is I want lambdas to be pure. So I want to define what purity means. Purity to me means that a function has no side effects. But what does it really mean? It means two things. A, the lambda doesn't change anything. And I think most of us will immediately understand what that means, right? So purity means you don't change anything. But it's equally important that your function, your lambda, doesn't depend on anything that changes. And I think both of those factors are extremely important. To put it in catchy words, I normally say a lambda should do no evil, it should see no evil. So both of those are important. You don't mutate, but you don't depend on something mutable. So in other words, any closure that binds to an external state is perfectly okay, but as programmers, it's our responsibility to make sure that it's an immutable state. So as long as the state is immutable, there is absolutely no problem. Well, remember where these concepts originated from. In pure functional programming languages, every single variable is immutable. So a closure can bind to any variable it wants to bind to. There is no risk at all. When we take these ideas and bring to imperative style languages, which supports mutability, it's our responsibility to make sure that the variables we depend on are actually immutable. So I wouldn't. So the bottom line is this: it's perfectly okay for a lambda to depend on any state within its reach, but never ever make a lambda depend on a mutable state. That is not going to make the lambda pure, and lambdas have to be pure. So I say I have no problem at all. And the reason is I want the lambda to be pure, and if the lambda is pure, it wouldn't depend on mutable state. So it's our responsibility to make sure it doesn't depend on mutable state. If developers are writing code where they make a closure depend on mutable state in external context, I think that's terribly wrong. We shouldn't do that.
Sure. I actually have here a comment from a guy called SH Maple saying functional code with state makes me shudder.
Functional code is what?
Makes me shudder. Do you want to comment on that, Mr. Maple?
Well, mutable. Yeah, mutable state makes me shudder.
Oh, mutable makes me shudder. Yeah. Code in general makes me shudder.
Okay, Ivan, can you proceed, please?
Okay, going back to streams. Besides the normal sequential streams, the new Java 8 API introduced also parallel streams. And they're very easy to use, and they have great power. So they look very tempting to use by the programmers. But there's always a catch in such situations, right? So are there any cases when you would not recommend using parallel streams?
I would like to reverse the question. Are there times when you would specifically use the parallel stream? Because I think the answer is not when not to use it. It actually is the reverse, in my opinion. And there are only few reasons when you would actually want to use it. And you're absolutely correct. I couldn't have put it better than you said. It's an extremely powerful tool, and we got to be very, very careful. It's kind of like asking the question, chainsaws are so powerful, Are there times when I should not use it? That's the easiest way to get the chainsaw taken away from us, right? So the question really is, chainsaws are so powerful, when I should use it and how careful should I be using them? So here's the problem. When you look at a parallel stream, the first thing to clearly understand one thing about parallel streams. Parallel streams say, I do not mind wasting a lot of computation with the hope of getting a result faster. So I'll give you a trivial example about this. Imagine we have a room with 100 people, and I was sitting around in a table and I forgot where I put my phone. So what I could do is I could walk to the first person in the room and say, is my phone next to you? And the person says no. Second person, no. Third person, oh yeah, it's here with me. I disturbed 3 people now, and it took me 3 units of work to find the phone. Great. So unit of work is 3, unit of time is 3. Well, or I could do something completely different. I could say to the room of 100 people, folks, I don't know where I left my phone. Could you all please check where it is? And everybody stops what they're doing and they check if there's a phone next to them, my phone that is. And in this case, that exact third person tells me they found the phone. It took me 1 unit of time, but it took me 100 units of work. And you may say, hey, Venkat, good news, you got your phone really quick. Absolutely. Well, bad news, you disturbed 100 people. Short answer, I don't care. So the point really is, I am willing to disturb a lot of people to get the result faster. Same thing applies to parallel streams. You don't mind doing a lot more wasted work with the hope you'll get the result faster. There are times when that's the right thing to do. There is plenty of time when that's not the right thing to do. For example, infinite streams. It wouldn't make sense to mix them with parallel streams, for instance, right? So the next question to ask is, what is the duration of computation? If your task is taking a relatively long time, the time you're going to spend spinning the threads and coordinating the threads becomes so minor compared to the time you're going to spend on the task. If the task is so short, you would be spending more time managing threads than the time you spend to execute the code. I was teaching a course on Java 8 recently for a client, and one of the developers, a pair of them, tried to take an example and re-implement it using parallel streams, and then they called me and said, do you see this code runs faster sequentially than parallelly, and why is that? Well, the reason was the computations were so quick that they were spending more time spinning threads and managing that than getting the work done. Your performance is actually poorer with parallel than sequential in this case. So second thing to consider is that your task must be long enough for the time you spend on a thread to be greater than the time you spend managing threads. The third thing to consider is the data size. If the data size is large, it makes sense to divide and conquer. If the data size is relatively small, you don't get much benefit in parallel streams because you might as well get it done quickly, sequentially, than to parallelize it and start the parallel mechanics to get going. So the question to really ask here is, I've got this tool, can I use it? Is not the question to ask. The question to really ask in this case is, I'm running this code, is it giving me a reasonable performance? If the performance is adequate, don't bother about parallel streams. If the performance is not adequate, then ask the question, am I going to get a better performance with this code by maybe rewriting it in imperative style? If that's the right thing to do, is that the solution I'm going to get benefit out of? Or maybe I do want to continue with the streams, but is now a good time to think of parallel streams? Does it really make sense in this context to apply it? So I would not start with the assumption that parallel streams are the right solution. Instead, I would actually consider that as the last resort rather than the first resort. The problem has to make sense. The problem task duration has to make sense. The problem size has to make sense. There are so many things that have to come together for a parallel stream to make sense. And so it's a question of, does it make sense in this given context, rather than does it not make sense in a given context? So it's more of a selection than a rejection that you really need to be focusing on when it comes to parallel streams.
So in case of question, just measure your performance and see both results. You can do it something like that, right?
Yeah, and measure is, you're right, but measure is also a little bit more of a stringent word. I normally use the word adequate. How does it feel to begin with? Hey, it feels adequate. Don't bother. It's good. Focus your energy on something else. Well, the performance is not adequate. Well, now measure it and get a feel for where the problem really is. And then once you know where the performance concern is, then I think it becomes clearer to see if parallel even makes sense in that case. Then apply the solution in that regard.
Yeah, I see. So we're 8 minutes left on our time. Guys, please send more questions on IRC if you want. We are running out of time. And Ivan, please proceed to your next one.
I think it will be the last one.
Okay.
So yeah, how would you explain FlatMap and its application to the Novice functional programmer? Because yeah, filter, map, reduce, it's a little bit close to the way of thinking, but FlatMap, at least for me, it was hard to explain to my students. And please don't use the M word for FlatMap.
I wouldn't. I want to switch over, if you don't mind, and show a quick code example just to kind of entertain this thought, if you don't mind.
We don't mind. Go ahead.
It would be Venkat without the code.
I want to actually show this code. I'm going to switch over in just a minute, so I'm getting to my directory here. I was not anticipating this, so I didn't have the things ready, but I think we can definitely do that here. So I want to switch over to, let me get my screen ready here. So there we go. So what I want to switch over here is to show actually a bit of a Ruby code. And the reason I want to show you the Ruby code is because I think it illustrates the problem in a nice way. So I'm going to go ahead and share my entire screen right now. And please do let me know when you're able to see my screen.
We are able to see it.
Wonderful. So what I want to do here is I've got a little list equals, let's say in this case 1, 2, and 3. But within this list, I also want to say 3 and 4, and then let's say in this case I'm going to say 6 and 7. Well, if you notice, what I have on my hand is a list with a list inside of that. Obviously, if I were to go through the list, if I say list dot, in this case, let's say puts list, and I'm going to just see what's in this list, and I can loop through and get one element at a time and print what's in this list. But clearly, we can see there's a list within the list. And if I ask the question list dot count, it tells me there are 5 elements in the list. Why is there 5 elements in the list? Well, 1 and 2 are 1. This entire list is the third one, and then 5 and 6 and 7 are the 4th and 5th. But I don't want this list of list. What I really want is just a list. So what I can do now is I can do a flatten, and then I can ask for a count. Notice it's no longer a 5. It turned out to be a 7. So in other words, I can get the count of the list as 5. But once I flatten, it gives me a 7. So what does flatten mean? It flattens this list into one single list. So the end of the flatten is 1, 2, 3, 4, 5, 6, and 7 are part of the original list. So the point I really wanted to make is this concept of flattening a list that we need to first understand, I think, in my opinion. Because if we don't understand what flatten means, it becomes hard to really understand what a flat map really means. Now let's go back and learn about what it means to use flat map. So let's take an example. I've got all the people in this Hangout right now. So I'm going to ask the question to the group. I'm going to ask, folks, could you please give me your email address? So we have people, but the result of this is email address of people. Now, easily I can ask you what kind of function this is, and your answer is going to be, well, I'll use a map function. Why is it a map function? Because it's a transformation from people to email of people. Hey, that was easy.
Excuse me, Venkat, we're only seeing my screen share on your screen, not your.
Okay, so let me fix that. So thank you. So actually, let's see how I'm going to fix it. I don't know how to fix it, so I'll just go back to my screen share here. It's for some reason it says Google Hangout, but it's only showing your screen. I don't know why. But we like looking at you also, Roberto. So that's no problem.
Thank you so much.
So the map really says, given a collection of people, give me the collection of email addresses. So it's very clear to us. We'll use a map. Now let's ask the question. When I say, could you all please give me your email address? Ivan says, I have 7 email addresses. Can I give you all of them, please? Well, sure. How could I say no to him? So I'm going to take 7 email addresses from him, and somebody else wants to give 1 email address. Somebody else wants to give 2 email addresses, and a 4th person wants to give no email addresses at all. Oh, wait a minute. Now the transformation of a map doesn't go from people to their email address. It goes from people to collection of email addresses. Oh dear, now rather than going from a list to a list, I'm going with a map from a list to a list of list. But I don't want a list of list in the end. I want the list in the end. Oh, guess what? Once I get a list of list, I can flatten it. Well, that'll be 2 steps though. I can perform the map, I can perform the flatten. Wouldn't it be nice if we just do one operation? Why don't we do map flatten? Well, let's rechange the word, flat map. So flat map simply maps a collection to a collection of collection and flattens it. That's pretty much what flat map really is.
Excuse me, Venkat, we're still seeing my own screen, or my own myself, not your screen. Sorry.
No worries. I'll try to change this here, but I'm not sure exactly where to click on.
I don't know, that green button in the side. Screen share.
Yeah,
and
I don't see a stop screen share. I don't see that here. But anyways, I think if there's more questions, we can answer that in the meantime.
Yeah. Anyway, we pretty much done with our time anyway. We don't have any more questions on RC so far. Anyway, people seem happy about your answers and very impressed about being so polyglot as well. So kudos to you. Anyway, I think we're gonna end it up right here. Thank you so much for joining us, Venkat, and for all your awesome knowledge that you brought us here to our book reading club.
Hey, thank you, both of you, for having me, and thanks to everyone who participated, and good questions as well. I really appreciate that. Thank you.
Yeah, so it was a awesome pleasure to have you here. And thank you so much for our audience, of course, to be here with us and send us the awesome questions that you did. And to Ivan, of course, that he also wrote some of the questions that he asked to you, Venkat. So we don't have anything lined up for the next book reading club, but we'll think of something. So stay tuned for the next few weeks, and we'll announce a next author and the next book, and we'll be happy to continue on with the book reading club. So thank you so much for joining us, guys, and see you next time.
Thank you very much.
Thank you.
Bye-bye.
Bye-bye.